presentation. It's the third presentation in Unit 2. It's titled, I'm Positive I Lost an Electron. It says, a positive attitude causes a chain reaction of positive thoughts, events, and outcomes. It's a catalyst and it sparks extraordinary results by Wade Boggs. The learning goals for this presentation are that you be able to articulate the role of the electron on atoms, and that you identify the subatomic particles involved in ionic notation. So what we already know that atoms are composed of protons, neutrons, and electrons, and we know the interaction of protons, neutrons, and electrons determine elemental properties. Also, we know that protons and neutrons exist in the nucleus. Okay, so we know that those are there. So now the electrons have to be somewhere else. Now what we learned in the lab is that changing the electrons changes the charge of an element only. It doesn't change the mass, and it doesn't change the identity. Okay, neither one of those change with changing electrons. Only changes the charge. Atoms are neutral when the number of protons equals the number of electrons. The reason why is protons have a positive charge, electrons have a negative charge. When you put those together, they cancel each other out and become zero or neutral. An electron is often referred to as an E with a subscript negative sign, indicating that it has a negative charge. Okay, it has a charge of -1. It's found in orbits around the nucleus, okay, in electron orbitals, and it has essentially zero mass. It's on the order of about 1/10,000th the mass of a proton, so since it's that small, we can say that it's essentially zero. Electron orbital is defined as the volume in which the electron orbits. Now, the electron orbital is sometimes referred to as an energy level. And the energy level is basically saying that the electron is confined to this specific circle. Now, this is kind of a two-dimensional way of trying to represent it, but it's just saying that the electron has to be there. It is related to the energy of an electron. The more energy it has, the more it jumps up these different orbitals. And the lower orbitals are always going to be filled first. That's one way of looking at electron orbitals. Another way is what's called the Electron Cloud. This is a little bit beyond the Bohr model, so this is after Bohr. And it says that you can't really say for certain that the electron's going to be there, but instead you have a probability of trying to find it. Electrons are very small and they're very fast, so a lot of times if you treat them as a wave, you end up getting what's called a probability function. All you need to know about this is that the exact location of an electron cannot be known. It's not that we can't just do it now or that our instruments aren't good enough, it's that you cannot know it. It's something called the Heisenberg uncertainty principle. Whoops. Alright, so elements and electrons. The electron has no effect on the atomic number or the identity of the element. The electron has no effect on the atomic mass, and that's a big one because people say, well, you're adding electrons, doesn't it add some mass? Yes, it's 1/10,000th of a proton, which is basically the same thing as a fly landing on your shoulder whenever you're getting your weight done, and then it makes essentially no difference. The electron does affect the charge, so it can take something from a positive to a negative charge. Atoms with different numbers of protons and electrons are called ions. Now, sometimes we refer to something, ions are the protons minus the electrons is equal to the charge. Now, one of the things that you should realize is that you can have a positive charge if you have more protons than electrons, say 7 minus 6. That would be a +1. You can also have a negative charge. So let's say that you have 7 protons but you have 8 electrons. That would give you a charge of -1. So you can have positive and negative ions. A positive ion is called a cation, and a negative ion is called, a negative ion is called an anion. So you can have cations or anions depending if something gains electrons or loses electrons. But one thing that you should realize is that the number of protons doesn't change. The number of electrons changes instead. You have something that's called ionic notation. Ionic notation is saying that the number of protons determines the element. So in each case you have iron. Now, if you change the number of electrons, you have to specify the charge of that particular ion. So for example, what this thing is saying right here, and this is way more common than these two, but it's just kind of showing you that there are 2 positive charges there. What this is saying is that there are 2 more positive charges than there are negative charges. So in other words, if you had a neutral atom, you took away 2 electrons. And when you take away 2 negative things, it becomes positive. You can also add ions to nuclear symbol notation, where you can just add the charge right there. Okay, so we want to fill in the chart below. We know that the electron is the new one, is an E with a minus. We know that it has no mass, and we know that it has a charge of -1. This is the symbol for the proton, so we can say it's the proton. we know that it has a mass of 1 and has a charge of +1. The particle that has 0 charge also has a mass of 1. It's a neutron, which is an N with a 0, and we write it as a neutron. Next, it says how many electrons are in an atom of Fe3+. And I'm going to leave this one for you as a chance for you to work your periodic table skills. But remember, this 3+ doesn't mean that it has 3 protons. It says the charge is protons minus electrons equals 3+. So what you need to do is you need to look up iron on the periodic table and say, where does it fit in there? Okay, you can know the number of protons, and once you know the number of protons, all you have to do is solve for the number of electrons. Okay, it says determine the number of each subatomic particle below. So the first thing you need to do is, this is nuclear symbol notation. So the one you always want to start off with is this. So you know that you have 17 protons. Once you do that, the next thing we generally go to is neutrons. Remember, this is referencing the number of protons plus the number of neutrons. So when you subtract these two values, you end up getting 20, which is the number of neutrons. Okay, once you've done that, now you can look at the electrons. You have a minus charge. That minus lets you know that there is one more electron than there is protons. Or you can look at it and you can say that there's 18 electrons. Another way of looking at it is you can say -1 is the charge is equal to the number of protons minus the number of electrons, and you can solve. Whenever you solve, you'd move the e to the other side, and then you'd add 1 to both sides, and you get e is 18. So you have 17 protons, 20 neutrons, and 18 electrons. The last example says chemists are used to dealing with large numbers of atoms. Instead of referring to individual atoms, we refer to 1 mole, which is 6.022 times 10 to the 23rd atoms. The last thing that we need to do is it says determine how many electrons are in 1 mole of copper atoms. So if we're going to do this, the first thing that we need to do is we need to say, okay, I have 1.4 moles to begin with, which means 1.4 moles is like saying a dozen, but instead of a dozen being 12, you have 1 mole is 6.022 times 10 to the 23rd. Okay, that's the number of atoms that you have. Okay, next, in every 1 atom, you'd have to look up the atomic number of copper. Whenever you say the atomic number of copper, remember, you have to look at the periodic table. Remember, copper is not CO. Okay, that's cobalt. So if you want to look up copper, you have to realize that, remember, copper is Cu. So whenever you look at Cu, you realize that copper has an atomic number of 29, which means that it has 29 electrons in addition to having 29 protons. So once you do that, you say for every 1 atom there's 29 electrons. So this is just like converting from meters to kilometers or anything along those lines. So the next thing that we need to do is we need to actually go ahead and solve. If you look, it's nice because there's nothing on the bottom. So all we have to do is take 1.4 and we can multiply it by 6.022 times 10 to the 23rd, and then multiply that by 29. And what you get is a very, very, very large number, like 2.44 times 10 to the 25th electrons. And you should realize at this point why we talk about things in moles. When we talk about atoms on a large scale, the numbers get to be so huge that they don't even make any sense. So instead we refer to things in moles instead of the number of atoms.